Now we're going to play one of my favorite games. It's called Name That Graph. Alright, so here is the graph, and you have to come up with its name. Okay, now obviously we're going to say, well, it looks like some variation on x squared. Yes, it is. Okay, and what is the equation for this? Okay, well, we know it's been translated in x. Okay, 3 units to the left, which would have this representation. Okay, that would just be the graph of x plus 3, the quantity squared, shifted 3 units over. And then we're going to flip it in x, okay, which is accounting for taking the opposite of the function. The function at that point was just a quantity x plus 3 squared, and when we take its opposite, we put that negative sign out in front. And lastly, we're going to pull it 2 units down. So this gives us that equation, okay? And one might be saying, well, does it matter which order we put things in, whether we translate and then reflect, or do it in terms of x and then in terms of y? In many cases it doesn't, but in some cases it does matter. So we're just going to give it a blanket statement. Do whatever pertains to x first. Do whatever pertains to x first, okay? And keep that in mind as we move through a couple more. Name that graph, okay? This is obviously a variation of 1 over x. How is it varied? Well, looks like it's been translated in x, 4 units to the right, which would have this representation, 1 over x minus 4. And then we look like we went 2 units up, okay? And therefore the final equation for this is, as we see, 1 over the quantity x minus 4 plus 2. And you can always validate this with a couple checkpoints, all right? Where's my y-intercept? Well, my y-intercept is when x equals 0. If x equals 0, then this is obviously negative 1/4 plus 2, which looks to be right where that y-intercept is. Likewise, if we wanted to find the x-intercept, we could, looks like here, looks like about 3.5. And that, if you put that in, that would validate that, okay? All right. What is the name of this graph? Well, you probably say, well, it looks like x cubed, but it's been all kinds of things going on with it. It is a variation of x cubed. And you say, has it been flipped across the x, or has it been flipped across the y? Well, the point in fact is, with x cubed, you get the same thing, whether you flip across the x or the y. It gives you the same thing. So to that extent, it's going to be better if we just say, let's flip it across x. It works better to say, let's flip it across x if it doesn't matter. Okay? Well, what else? Well, we shifted it 2 units to the left, which would be accounted for with this notation. And remember, we're going to do what pertains to x first. So we agreed that we're going to flip this in x, which we're going to take care of now by taking the opposite of all which we have there, which will be accounted for in this notation. And then finally, we're going to pull it 4 units down to give it its final name. The function f of x is the opposite of the quantity x plus 2, quantity cubed, minus 4. Again, a couple good checkpoints. Where's this y-intercept? Well, it's going to occur when x equals 0, which is going to be what? 2 cubed, which is 8, offset by a negative 8 minus 4. So it's going to be way down there, as you would expect, okay? All right. Name that graph. Obviously a variation on the square root of x. But how? It's involved a number of things, hasn't it? Okay. Our square root of x generally is flowing in the opposite direction in the first quadrant. But this has been flipped over, okay? It's been flipped in y, it's been shifted in x, and shifted in y. So remember, we're going to account for the x items first. So the x items first says, it looks like it's been shifted 3 units to the right. Now remember, shifting 3 units to the right is evaluating f of x minus 3. So that's what we did, f of x minus 3. Now we're going to do what pertains to y. Now, what happens if this has been flipped in y? Everybody should agree to that. When we flip in y, we have to negate all the items of the x concern, okay? So we have to negate, we have to take the opposite of the x items, which is the opposite of that radicand, right in there. Notice I'm taking the opposite of the collective thing, okay? The opposite of the collective thing, as you see right there, okay? Now I can distribute that, and I end up with this expression. Now, lastly, we're going to pull it 2 units down, okay, for our final expression, all right? Now, it would be good to see whether or not this is a proper name, so we're going to check our intercepts, okay? By letting x equal 0, we're finding the y-intercept. If x is equal to 0, then this equation just becomes y equals the square root of 3 minus 2. Square root of 3, about 172. Less 2 is certainly going to make it negative as depicted there, okay? Also, if we want to check the x-intercept, we let y equal 0. If y is 0, then f of x is essentially 0. And that's what we have at this stage. We shoot the 2 over to the other side where it becomes positive. We square both sides. We subtract 3, and then we find x is negative 1 is the x-intercept, as shown here. Also, you can also check for the domain of this function. The domain of this function would say that the opposite of x plus 3 needs to be greater than 0, which should agree and show us that the domain is all from negative infinity up to and including 3. Okay, one more. Okay, here we go with the cube root of x. Looks like a cube root of x variation. Again, this looks like, has it been flipped in x or y? Well, again, cube root, just like the x cubed, due to its symmetry about the origin, you flip it in x, you flip it in y, makes no difference. I always say, if it makes no difference, let's call it a flip in x, okay? So here we have, we're counting for a movement in x, a flip or a reflection in x, and a movement or translation in y, okay? So it looks like it's been shifted 2 units to the left, which is as stated here with the new function name. Then we're going to reflect this in x, which means we're going to take the opposite of that which is there, okay? Taking the opposite of that which is there, which is accounted for right there. And then lastly, we're going to pull it up 3 units, and that is our name. And again, not a bad thing to check for some intercepts perhaps, okay? If x is equal to 0, okay, what is our y-intercept? If x is equal to 0, we've got the cube root of 2, which is some positive number, but then it's being negated by this sign here, which when we add 3 to it, okay, we'll shift it right up to this location, okay? And that is it for Name That Graph.